The second factor we're going to look at is the concentration. Now, in a reaction, just as we know, we have the reactant side and then we have the product side. As reactants disappear, products appear. As the products disappear, the reactants appear. That is it for reversible reactions. Now, here in the notes, this is what it says. The rate of reaction depends on concentration of reactants. If we decrease reactant concentration or increase product concentration, equilibrium shifts to the reactant side. Now, let's think of it this way. When we decrease one side, the reaction will act in a certain way to replace what we decreased. If we decrease one side, if we decrease the concentration on one side, the reaction will act in a way to replace what we decreased. So here, if we decrease the calcium carbonate concentration, this reaction will act in a way to replace what we've decreased. Therefore, equilibrium is going to shift to the left. The reason is because here, this reaction will now go faster so that we can replace what we have lost. That is what the notes imply. If we decrease the reactant concentration or increase the product concentration, equilibrium shifts to the reactant side. So if we decrease this side, equilibrium or the reaction will ensure that whatever we have lost will be replaced. Good. Now the next thing is that if we increase one side, so for example, if we increase this side, that means we have a lot of this reactant. Therefore, we will need to get rid of this lot. So what happens? In order to get rid of this lot, equilibrium is going to shift to the side. So this reaction is going to be faster so that we can easily get rid of this lot because it is disturbing us. Therefore, equilibrium is going to shift to the other side so that here this reaction can go faster and then we lose the excess concentration we have added. So the other part is if we increase the reactant concentration or decrease the product concentration, equilibrium moves to the product side. The reaction will always adjust itself so that equilibrium could be brought back